We start our discussion about atomic theory with Dalton atomic theory. Here we have ancient theories named Democritus, that's a Greek philosopher. He thinks about matter. What if we cut matter? He thinks deeply that is there any end to the part of the pieces when we cut the matter? Then he concluded that he thought that there is an end to the cutting. Then the smallest part he called as atomos or indivisible. Here the learning outcomes. You may be able to explain what atom is according to Dalton theory. Dalton's atomic theory proposed that all matter composed of atoms, indivisible and destructible building blocks, while all atoms of an element were identical, different elements had atoms of differing size and mass. So all atoms of, let's say, oxygen will be in the same size, identical, the same mass, but differ from hydrogen. For the atom of hydrogen, all in the same size and mass, but differ from the oxygen. The postulates: 1. All matter consists of indivisible particles called atoms. 2. Atoms of the same element are similar in shape and mass or size, but differ from the atoms of other elements. Three, atoms cannot be created or destroyed. 4. Atoms of different elements may combine with each other in a fixed simple whole number ratios to form compound atoms. So here we have copper 2 oxide. Copper is Cu and oxygen is O. The two type of atoms join together in ratio 1:1. 5. Atoms of same element can combine in more than one ratio to form two or more compounds. For example, SNO can form SO2 or SO3. So the ratio is 1:2, here 1:3. So there is different ratio for the same element. Six, atom is the smallest unit of matter that can take part in a chemical reaction. So here, two molecules join with one other molecule, then form the product, change into 2 For example, you have H2 join with H2 join with O2, then we'll produce H2O plus H2O. We can write as 2H2 plus O2 to form 2H2O. So the number of hydrogen 4, the number of oxygen 2, 2 times 1, 2. Somehow, there are drawbacks of Dalton atomic theory, the weaknesses. The atom that Dalton said as cannot be divided actually was wrong, because atom has subatomic particle we call as proton, neutron, and electrons. According to Dalton, the atoms of same element are similar in all respects, but we know right now there are isotopes, atoms of one element with the different mass of atoms. So Dalton is wrong in this case. For example, chlorine has two isotopes with mass number of 35 and 37. But according to Dalton, all atoms in one element have the same size, the same properties. Dalton also claimed that atoms of different elements are different in all respects. But here we know the term isobars. You may never heard, but isobars actually is atom that the same mass but different element. For example, here argon 40 and calcium 40. So different element but the same mass of atom. That's we call as isobars. But according to Dalton, different element, different atoms in all respects. According to Dalton, atoms of different elements combine in simple whole number ratio to form compound. But we have example here, not always simple. There are a lot in a complex ratio, such as in sugar. The ratio here a little bit complex here, 12 to 22 to 11. But still, we have the theory that still we use until now, that is law of constant composition and multiple proportion. The law of constant composition in chemical reaction, such as in FES, 56 plus 32, 88 grams. The Fe is 56, the S is 32. So the ratio combination in the compound always constant. Dalton was the first person to recognize a workable distinction between the fundamental particle of element or atom that of a compound molecule. In the summary, the ancient Greeks proposed that matter consists of extremely small particles called atoms. Still remember? This is Democritus. Dalton postulated that each element has a characteristic type of atom that differs in properties from atoms of all other elements, and that atoms of different elements can combine in fixed small whole number ratios to form compounds. Samples of a particular compound all have the same elemental proportions by mass. For example, in water, H2O, the mass proportion is 2 to 16. So the ratio is 1 to 8 for hydrogen to oxygen. Element, when joined together to form compound, a given mass of one element will combine with masses of other elements in a small whole number ratio during any reaction. Atoms neither created or destroyed, as I have explained. H2 and O2 to produce H2O. There is no element here that destroyed or created. So what happened is only the different composition. So hydrogen in 2 molecules of H2 and 1 molecule of O2 join and then rearrange to be 2 H2O like this. So there is no created nor destroyed. The same. The difference is the composition. Next lesson is about, after we finish Dalton theory, we'll continue with J.J. Thomson and Ernest Rutherford. Here some exercise. You can answer by yourself in Indonesia. What atom compose sodium chloride? Na and Cl. Water, H2O, H and O. Sulfuric acid, H2SO4, HSNO. Besi or iron, Fe. That's all. We'll continue with Thomson atomic theory for the next lesson.